These two examples, we are going to be doing integrals of exponentials. This one's going to be treated a little bit different than this. This is what it looks like most of the time. You're going to have an exponential that's going to have some power to it. And recognizing that to use substitution, it's because this was a chain rule when you had originally done the derivative. So trying to figure out what piece is the chain rule, kind of the inside piece, and letting that be your u. So if you were going to do a derivative, this is your chain rule piece. So we'll let that equal u, and then we'll do du. Derivative of this is going to be 10 dx. And then let's isolate the dx. So we'll bring the 10 over. So that'll make it a 1 over 10 du equals dx. And then I'm going to rewrite this to put it in terms of u to make our antiderivative a little bit easier to work with. So I'm going to replace dx with 1/10 du. The 1/10 I'm going to put on the outside, and then my 10x is going to be replaced with u, and then I'm going to finish the rest of the dx substitution with du. So to do the antiderivative, if you remember that if you have an exponential and the derivative of that exponential is itself, then if you're going to do the antiderivative of e to the u, you're basically going from here back to there. So you're going to get an e to the u. We'll drop the 1/10 down. And then since we're doing indefinite integral, we'll tack on the plus c. So it'll end up being, when we resub our 10x back in for u, 10x plus c. And that is our integral. So if you need to double check it, if you do the derivative of this, the derivative of this would be itself, and then times the chain rule piece. The 10x is going to get multiplied down with the derivative of 10x is 10. It's going to be multiplied with the 1/10, and it's going to cancel it away. This one's a little bit different. This one is that if you remember, when you have some other base and you do its derivative, the derivative of this, if I do all the pieces to it, is going to be itself times the derivative of the exponent, there's the chain rule piece, times the natural log of the base. And it doesn't exist here because you'd have the natural log of e. So if we were isolating this, and we kind of rewrite this, if we wanted to get the a to the x by itself, we would divide that piece over. So it's 1 over the natural log of a equal our y prime. And then equals a to the x, and then times the derivative of that. So that's your dx. That's your du kind of a feel. So basically, when we're going to do our antiderivative of this, we would have done a derivative, and you would have had this natural log of a floating there. So a natural log of 5. Well, it's not there on the answer, which means we need to undo it with the natural log of 5, and then 5 to the x plus c. So there is our antiderivative. So we need to have that piece to undo it. And that was two examples that involved exponentials.